There. Okay. So my name is Michael Evans. I work at LivingSocial, and I'm here to talk about annotation processors. How many of you have written an annotation processor before? Awesome. Okay, so just Jake. That's really good. How many of you know what annotation processors are? All right, awesome. That's good. And have any of you ever even seen like a custom annotation yourself? Like, I assume you've seen what they are. Okay, cool. You might as well just play along. I'm going to show the slides anyway. So I'm going to explain you annotations. If you've never, like I said, if you've never seen them before, this is the code that you get when you hit New Project in Android Studio. The little things that are yellow override, that's the annotation. So annotations came around in Java 1.5. It was kind of just like this very vague definition is just metadata on any element in a class. And then there's some ones that came with 1.5, override, deprecated, suppress warnings. You've probably seen these before. If you haven't, they're just kind of things that the compiler can give you some information. So if you at override a method and it's not found in a parent or implemented interface, you get a compiler error. There's deprecated, which gives you a compiler warning if the method is used, so you can know that maybe you shouldn't use it anymore. And then there's suppress warnings that you can tell the compiler, like, I know what I'm doing. Then some little more Android-specific annotations. The Sport Annotations library, which is pretty awesome if you haven't used it before. There's things that kind of tell the compiler, like, I know this is going to be null or might not be null. It'll kind of give you a warning if you don't do a null check or you do one that you don't need to. One's for resource types. So since all resource IDs are integers at the end of the day, if you try and pass in a string resource to somewhere where there's a layout resource or something, you'll get a compiler warning. You can annotate methods that are going to require permissions. And then a really neat one that just came out is @keep. And then you don't have to kind of screw around with ProGuard files. You can just @keep a class or a method or something like that. I wrote a blog post about this. It was pretty popular, so you can check that out. It's really easy to add to your app. You just kind of just add this and then just start annotating away. And if you want more information about this, there's a talk right after this one, I think, Tools of Trade, and he's going to talk about this among some other things. So now, like the actual reason we're here, annotation processors. So annotations came around in 1.5. Annotation processors came around in 1.6. They were integrated into the compiler, which is kind of something you don't really need to know about, but it's always interesting to hear. So why would you want to write an annotation processor? So they're good for two main things. One is maybe generating code that is repetitive or might be like prone to bugs and copy and pasting or something. Or then maybe some code that's not trivial to write, but you don't want to have to write it yourself every time, so you can have the computer do it for you. The compiler can write it for you. So some annotation processors you might have seen that kind of are good examples of this is Jake wrote one called Butterknife. I assume everybody's heard of. If you haven't, it's pretty awesome. So this is some code that you might write to bind some views in your activity. It's kind of a lot of boilerplate. You got to make sure that you don't, like, if you copy and paste, you make sure you change the IDs and the casting and stuff. And so with Butterknife, let's see if this well, anyway, the magic move screwed up. But you can see you can just kind of annotate the fields and then call Butterknife.bind, and it will do the kind of code generation to handle that find view by ID nonsense for you. Another good example of an annotation processor is Dagger. This one I don't really think fits under the easy to write boilerplate. It's kind of more under the magic that is complicated that let the computer do for you. It's a dependency injection library. You can just kind of only show the injection part, but you just annotate @inject, and then somewhere else you'll declare the provide the dependencies, and then you get them. It's pretty neat. It goes into way deeper scope than this talk, so you'll have to kind of look online to find some videos about it. Another one that's pretty new, that's really cool, and kind of the one that actually got me interested in learning about annotation processors is called Deeplink Dispatch. If you've ever written any code for deep linking, you'll know you'll have some intent filters in your manifest, and then you'll have an activity that kind of parses whatever URI gets passed through the intent, and then you'll need to figure out kind of which activity is the one that's going to get the extras or something. So Deeplink Dispatch is pretty neat. It just, you annotate your activity with this @deeplink method, and then it pretty much does all the magic for you. You get an intent with a bunch of extras, so you can get the path parameters or query parameters. So I definitely recommend you check that out if you're doing any deep linking. And then another one that's pretty new that I also just recently heard about, I haven't used it, is called Galette. And basically you just create a Google Analytics tracker, and then you can annotate your methods with send event, and when the methods get called, it sends the event to Google Analytics. So you don't have to litter your code with a whole bunch of like tracker.track methods. So let's get into actually talking about writing one. So last year at Droidcon NYC 2014, Jake gave a talk called Annotation Boilerplate Processor, or Processing Boilerplate Destruction, which was really good, but his knowledge is like way more comprehensive than my own, and kind of blew my mind. And it was a little too much information, I think, for me. And I learned best by example, so I just kind of want to write my own. So I'm going to walk you guys through writing like a much simpler version of an a real simple annotation processor, and then might help you kind of understand some of the top stuff that Jake was talking about. So the example that we're gonna go through is one that basically handles start activity for result and on activity result. So if you've worked with Android for a while, you've probably seen this. It's used a lot by this, like when you want to interact with the system, maybe get an image from the camera and you don't want to write your own camera class, or pick a contact from the contact picker. It's extremely popular among third-party payment libraries like Google Wallet, Android Pay and PayPal. So I named the library Aftermath because it's what happens after, I guess. And to give you an idea of like what kind of code, if you've never worked with Google Wallet or Android Pay, is like, this is kind of the code. This is actually the sample code from the Google Wallet example. So the first thing you do is you have this masked wallet request, and that gives you the payment information on the user's account. And you don't have to, please don't like read this, it's really bad. Definitely don't follow their sample. But the masked wallet is kind of just gives you the masked like last 4 digits of the card so you can display them in a UI. And then they have some error status that you have to handle in case that like Google Wallet isn't, or Google Play Service is not on the device. And then when you hit the purchase button, then you have to request a full wallet, which actually gives you the credit card number, and then that's a whole separate code. And then what happens if the user changes their payment method? Then there's a changed wallet thing, and then there's more result error codes for different things. It's like a really big disaster. So it'd be kind of cool if you could break it up with some methods, kind of like Butterknife-esque. So project structure of an annotation processor, there's lots of different ways to do it, but the way that I've kind of seen that's works best is kind of breaking your project into a couple different modules. So the one that's I see most often is having two, one that's for the compiler itself and one for kind of the API that your app will call. I found that 3 is better because a lot of times people use hacks to make the two module approach work, and I'll get into that a little bit more. So there's going to be an annotations module, that's just a jar, plain old jar. A compiler module, that's also a jar, and then kind of an API module, which can be a jar or AAR. So let's talk about each of those modules. So the first one, the annotation module, that one's pretty straightforward. It's just going to contain all the annotations that you're going to use in your processor. So in this case, we just define one annotation on activity result. This is the entire class. If you've never seen what an annotation looks like, it's not a whole lot of code, but there's some interesting things going on. So first you use this @target annotation, and that sort of tells what kind of element that this annotation applies to. So there's things like field, method, parameter, constructor, like package. It can be pretty much anything. If you omit it, I believe it's applicable to any any code piece. And then the other part that's interesting to look at is this is the parameters for the annotation. So you can declare string or integer or whatever you want. And then you can also have default values for these. So if like this is not defined, then it will automatically just default to -1. So that one's pretty straightforward. Now we're going to talk about the processor. And so the annotation processor module is just a Java module. It just runs in Java C. It's separate from your application process. The only kind of interesting thing about it that you need to know to get started is you need to register your processor with the compiler. And you do this by creating a special file. So normally you have your source files in like source and then some package name, source main Java. Then there's a meta-inf services directory, and you create a file called javax annotation processing processor. And then inside that, it's just a plain file, and you just put the class name of your annotation processor. And this is kind of something that is like boilerplate, I guess, if you write a lot of processors or something. So if you like annotation processors, you can use an annotation processor called autoservice in your annotation processor, and it will actually you just annotate your abstract processor class with an annotation, and then it will generate that file for you, so you don't have to do that. Yeah, we're lazy, so we like annotation processors. So abstract processor is the kind of key that makes this work, or it's the best way to go. You can use just processor, but it's kind of what's recommended. And there's 4 main methods that you want to look at when you are implementing this. So the first 2 are really easy, supported annotation types and supports source version. You can just return the set of annotations that you want to support. So in our case, it's just the one. And then the supported source version, it's just recommended to always support the latest. The next method that we want to look at is init, and it has this processing environment parameter. You don't really have to do a whole lot in there, but you might want to keep a reference to a whole bunch of the things that are on the processing environment. So each of these is going to get used later. So filer is used to write source files that will get generated when the processor runs. The messenger is used to kind of provide information to the user. So that comes out through like compiler warnings or compiler errors. And then 2 static methods or classes with a lot of static methods, element utils and type utils, and we'll use those a little bit later. And then you get to the process method, and this is pretty much where like all the actual annotation processing happens. What might be useful if you're kind of just playing around with it is you can just kind of iterate over all of the methods that are annotated with your annotation, and then you can't use system.out.println, that doesn't work, so you can use the messenger to print out a warning, and in this case it's just going to print out the method names of all the methods that are annotated with that annotation. And I kind of want to just talk a little bit about that set of type element. So element is kind of this interface that exists that kind of describes every piece of code inside your classes. And so this is kind of a really simple class, but it kind of gives a good explanation of the different types of elements. So a class would be a type element, and variables would be a variable element, and methods would be executable elements. And they have a whole bunch of methods on them that allow you to kind of get more information about the class. So you could use get enclosing element or get enclosed elements to kind of move up and down the tree that kind of gets built. You can use like type element to get the qualified name, which would be the fully qualified class name. And then for a variable element, you can use like something like get constant value to get the value of the variable. And I'm about to get into a whole bunch of code. It's kind of unfortunate, but I tried to get it as concise as possible for the slides, but I'll have all the code posted at the end, so if you miss something. So basically what we're doing here is we're going to look at every method that's annotated with onActivityResult, and we're kind of just going to create this, we have this class called binding class, and that's just going to strip out a lot of the metadata about the method name and the request code and a whole bunch of things that we need, and we're just going to kind of store that. And then after we store that, we're just going to iterate through all of the binding classes and then have them write something to a file. And so we'll talk about what they're going to write. So this processor kind of followed along with Butterknife. And if you've never looked at the generated code for Butterknife, it's pretty similar to this. For every activity, it will generate basically an onActivityResult method that kind of does all of the stuff that you need it to do. You can write code like this, where you just have a whole bunch of strings, but Java doesn't have string interpolation, and Java source files are not a lot of fun to write as strings. So luckily, Square has a library called Java Poet, which is a pretty awesome API for generating Java source files. And there's a lot of code up here, but what this does is it's going to generate a class called Hello World and have a main method that just prints out Hello Java Poet, and it handles generating like all the import statements for you and pretty much everything you need about the syntax and stuff. So we're going to look at the binding class that I talked about a little bit ago. And so this basically just has two methods on it. One that will create a map of the request codes to the actual onActivity result method bindings. And then there's a write to filer, which at the end, when we actually write these, will generate the method that you saw before, but without having to write a whole bunch of strings. So this will generate the class signature, and then this part of the code will generate the onActivity result method, just iterate through and add a bunch of if statements. And so then the last piece is, so we have this annotation, and we have this processor that will generate these source files for us. But we need to kind of put them together so that it will work in our app. So the API for this library is like super simple. It's just a static method on this class aftermath. And it's also really simple. So like I said, most of the work is really in the processor. So the method just basically looks up for a source file through reflection that matches the same activity name with the $$ aftermath that we saw in the source files. And then it caches it in a map because reflection is slow. And if we find a match, then we just call onActivity result, and we pass through all the parameters and the target, which would be this. And so looking back at the code, this is sort of what it looks like. So the target would be your activity, and then we're just going to call those methods. It's pretty similar to what you might write by hand at the end of the day, but you don't actually have to write all these like if statements and stuff. So tips when you're working on these, because it's not super simple the first time, is that you can't really, you can only generate new files, and you can't manipulate already existing files, which is kind of something you might think you want to be able to do, but you can't. So I think the preferred way to do that is through a Gradle plugin. Another thing that's pretty awesome to use is this, you may have seen, is a Gradle plugin called Android APT. And by default, if you use an annotation processor in an Android project, Android Studio doesn't show you the generated source files, but if you use this plugin, it does. And that way, when you're debugging things, you can kind of see exactly what the generated code looks like. It's kind of hard to debug if you don't have that. And another awesome tip is to use this library from Google called Compile Testing, and it has a really sweet API that allows you to kind of pass in a Java file and then tell it which annotation processor to use, or multiple annotation processors, and then verify that it compiles and that the code that comes out kind of looks like you'd expect. And then this, like I said, this code's all on GitHub already. Definitely, if you're interested, take a look. I'm also going to add support for a few other things, like maybe filtering on result codes, so that methods only get called if like you have a certain result code okay or something. But this is a really good place to look. There's really not a lot of good examples of like well-tested annotation processors. So definitely, like I said, look at Butterknife, that Deeplink Dispatch. I remember after Jake's talk last year, I asked, where are some good resources? And Jake's answer was sort of like my talk and the ones that I've written. So definitely check those out. There was also a talk at Droidcon Germany by Hans Dorfman that was really good. So definitely check that out. And then you guys can explain me applause now. I think is a good time. And I know